Good morning, everyone. Welcome to the already fifth webinar in the sequence on the Digital Academy from SESAR. We have quite a lot of registrants for this webinar. I think this morning I heard that we're almost reaching the 500 registrations. I don't know how many are here already, but it's time to start. So we start. I'll start with giving a little introduction of, well, that's a really bad start because I didn't share my presentation yet. Now I guess I do. Are you seeing it? That's weird. Now my own presentation doesn't start. Let's try again. How about now? This is better, I guess. Yeah, finally. Okay, apologies for this slight hiccup. So the first four webinars that we had were on the master plan, on higher levels of automation, about machine learning and artificial intelligence. And we had last week the one on remote tower in the context of virtualization. So this is another webinar on virtualization, this time focusing on Virtual Center. All the previous four webinars are still available as recordings through our website, including the presentations and the questions and answers. Also, this webinar will be recorded and will be published afterwards. Note that we still have a lot more to go, starting next week with already next Tuesday, the one on CNS. In case, I guess by now, most of you will be familiar, who have already seen these webinars before. In case you have not, you'll see that on the right side of your screen, you have a couple of tabs: chats, questions, polls, and people. Most of you have found the chat. I can see that happening. But if you want to pose questions to our speakers, so at the end of this webinar, we're going to have about 25 minutes for questions and answers, for a little debate between the panelists. Put those questions in the questions tab and not in the chat. So our speakers keep an eye on the questions tab. There's also for them the opportunity to already start answering those online as the webinar goes on. Now I'll give a little of an introduction, a background on how we come to this topic of the virtual center. And it's all related to the airspace architecture study. So if you look at on the bottom side, the airspace architecture study came out in March 2019, which was on request of the European Commission. And it was followed by another request to also, from that vision, translate that into a transition plan. So what are the steps that we need to take to actually get there, which was delivered in September 2019. And there is an ongoing study of the Commission on the regulatory impact of all the work that is being envisioned. Now, this all is tightly related to research work that has been done within SESAR. So in SESAR 1, we started with a feasibility study on the decoupling of the controller working position and the flight data processing system. We had some projects on system-wide information management. In SESAR 2020, Wave 1, which closed not so long ago, we started in more detailed researching business models, use cases, high-level architecture, architecture steering principles, technical architecture, and also removing the qualification constraints, allowing controllers to operate in multiple airspaces. So that all is still ongoing research, let's say, consolidated now in Wave 2 into one solution, which is still ongoing at this moment, with a question mark about what we will still need to continue in Wave 3. So all the speakers that you see here have played a role somewhere in this process, and I'll introduce them later. The approach of the airspace architecture study was slightly different from what we do as a regular scope within SESAR, which is usually focused on airspace solutions, on operations, on technological enablers. The approach that we took here is to take an integral view from a regulatory service perspective and the airspace, operations, technology, and the infrastructure below, to see if when we combine and look at that in a more holistic view, if we can get more out of that than just the sum of the individual elements. So the objective was two sides of the same coin. On the one side, just increase of capacity and through, let's say, better capacity of airspace. But on the other hand, also increase the scalability and resilience, knowing that delay minutes do not only come from a lack of capacity, but also a lack of ability to adapt to disruptions. So this gives a bit of a very high-level view of how air traffic control is organized these days, or how it has been organized conventionally, let's say. So air traffic control is provided state-based. That's what you see at the bottom here. Two states presented here. And on the upper side, we see aircraft flying on fixed routes through fixed national airspace structures, which makes it limited scalability and limited capacity as well. So the airspace is divided in FIRs, so the flight information regions, and within that in sectors. And every sector is, or a controller is allocated to an individual sector. And every area control center, which could have multiple centers, multiple sectors, has its own flight data processing system and its own CNS underlying infrastructure. So the ground-based sensors, things like the antennas, the ILSs, VORs, NDBs, whatever. So this is, let's say, originally what it is. Where we're trying to go, and this is a very high-level picture of the vision that we have, is to move towards a situation en route, so let's say in the higher airspace, where aircraft can fly just on free routes, so not on a fixed route basis, but on free routes. The airspace underneath is dynamically configurable, which means that it's not predefined what the sectors look like. They can be reconfigured, and they can also be flexibly reallocated to different controllers, different centers, and taking over control from different states. Controllers can be flexibly allocated to any of these sectors, and they all run on just a few flight data processing systems, or what we call here ATM data services. So we're actually moving towards a services architecture. So away from one legacy system, just the services, a set of services in the different layers that we see here. And that also means sharing more and more of the CNS infrastructure underneath. This is a picture that goes slightly beyond what the results was, of the outcome was of the airspace architecture study, which has been further elaborated in the European ATM Master Plan 2020, which came out not so long ago, which shows as well, in particular, the impact of new entrants. So new entrants being what you see on the top side, the high altitude platforms, the ultrasonic flights, solar flights, rockets. Then within the regular ATC context, also RPAS integration, so remotely piloted aviation systems or aeronautical systems. And then on the bottom, use-based operations, so drone management. So those are the newcomers that somehow will have to be integrated into the ATM system or be connected to the ATM system. And all, again, in a services view, services approach. So the key drivers for going to the services approach is separation of concerns, because that allows for scalability. So independently scale up capacity of each of those individual service layers, which also leads to more resilience, because if anything goes wrong in one of those services, in one of those service layers, you just take the service next to it of the same service layer, and the total concept will still keep running. Also allows for more flexibility. So both in terms of competition and collaboration, it allows for the introduction of new business models. Last but certainly not least, it allows for a much easier evolution of the separate layers. So instead of having one complete integration of every let's say the whole system, which makes it pretty hard to do new releases, if we just have individual service layers, you can puts innovation in each of those service layers without impacting the layers above, except for their performance. And all of that is possible, and that is important, I think, to understand. The reason that we couldn't do this in the past is that the reliability and the latency of the ground-ground networks in the past was not that impressive, which means that all those services had to be close to each other to make sure that everything would be safely and reliably connected. But what we see, what we have seen in the past decades, I think, is a rapid increase of reliability and low latency data exchange networks that does allow for the geographic decoupling of all those services, and therefore allows for this services-based approach. So I'll leave it to that because I have 4 speakers here that are going in much more detail into what this really means in practice, grouped into 4 different areas. So the operational use cases, the business perspective, and the technical state of the art. So on the operational use cases, we have Maurizio Romano from TechnoSky ENAV. On the business perspective, Thomas Buchanan from SkyGuide. And on the technical state of the art, Richard Bollier from Thales and Maarten van der Lee from Frequentis. That ends my introduction. I will give each of the speakers an individual introduction with a little background of what their relevance was in the context of this topic. And with that, I will close this introduction. And we start with Maurizio. So Maurizio has over 40 years experience in real-time simulations as a scenario designer within the ATM context. He worked on the concept of operations development within the European 6 framework program, later in SESAR, and nowadays in SESAR 2020, with the responsibility to coordinate the validation management group and to properly coordinate all real-time simulation activities. In SESAR 1, Maurizio has been the area coordinator for airborne spacing through sequencing and merging, ASAS, SNM, and in that context has been responsible for the preparation of experimental validation design in ENAV Experimental Center for the SESAR framework. In SESAR 2020, Wave 1, Maurizio has been a solution lead for the Solution 59 on Data Center for Virtual Center in the context of delegation for airspace, and he's currently the SESAR project manager for Wave 2, Solution 93, which is ongoing research on the operational use cases. Maurizio, the floor is yours.
Thanks, Ruben. Can you hear me?
Yes.
Good morning, everybody. Maurizio Romano speaking. Thanks for this quick introduction, and I will give just an overview of the operational use case with a specific background also for the project of Solution 19 that aims to investigate some operational use case in context of delegation of airspace, and as well just a bit distinguish of the air traffic service units. First, the PJ10 Wave 2 PROSA is managed by the DFS, and Solution 93 is part of the project inside the PJ10 that is called Delegation of Airspace among Air Traffic Service Units. And we have objective is to develop the use case for the delegation of EATS services and contingency and to describe the operational procedures. Second step is to progress with the virtual center concept is to support the use case for static and dynamic contingency for delegation of airspace. It will be based on the different phase of flight, mainly starting with the basic use case in the route phase of flight, and then the interaction with the terminal maneuvering area, and as well external services like ATCFM in order to see some dependencies in a previous phase of flight during the cross-border operation, or if dependencies of the delegation services. It should be used by several ADSP. ADSP means ATM data service provider, and it should be considered for the infrastructure layer on the virtual center. It should be used mainly on the virtual center architecture, but also some implementation of the different architecture should be used in order to have a proper delegation of the airspace between flight information region. Of course, it should be divided in operational thread, technical thread, and validation. We do have different validation maturity criteria, and we will test in a stepped approach at the beginning the requirements on the operational and technical side, and together we will have several real-time simulation in order to test different environment, different scenario, and different traffic complexity in order to be close also with the real air traffic controller and the real world in a simulated environment. Delegation of air traffic services, there is a part of the information layer with infrastructure layer, and based on this architecture already defined in the previous project in SESAR 1, we start with some use case and to have an inventory of use case with the operational needs, process, roles and responsibility, and working method. So as you can see here in the blue in this table, we are in the blue screen of the air traffic service units and interaction of the delegation of airspace among air traffic service units. And based on this inventory, I will tell you several use cases to test in this specific environment. First, we start with the PJ 15.9 for the operational concept study, because based on the delegation of airspace with the associated virtual center architecture, we consider a first beginning of the workstream analysis of delegation and contingency. Then we based on the existing operational reference model that they already existing, some delegation with the current infrastructure. And based on this infrastructure and virtual center, there are some new tasks and to be processing with the air traffic controllers, supervisor, delegating ATSU, delegating supervisor, that I will spend a couple of words later on. In SESAR 1, with technical project, we start with the night use case, and it is based on a fixed environment, low traffic, because this night use case should be easier to manage the traffic with the simple use case. And then based on that, we have a lot of use case in terms also of the external air traffic ITSP, cross-border operation, civil-military interaction, or in contingency use case. This is quite important also to set this particular use case. What would happen? This is a schema during our operational requirements that we have in the current situation, air traffic service 1 and air traffic service 2, that is totally separated. Every FIR should be managed the particular sector with a common ADSP and common infrastructure. In that particular things, in that particular delegation, after the delegation, we should have a contingency use case that the air traffic service unit should be delegate the entire sector of that particular FIR, or should I delegate part of the FIR sector into another RDSP? And based on that, we discovered and we have a process of the delegating supervisor, receiving supervisor, that they will exchange some information with the receiving supervisor about the delegation. And there are specific roles to assess if safe to close position of the controller delegated sector after the delegation was completed. So it is just a stepped approach in order to talk with the supervisor and the delegating air traffic controllers, also with the ATSEP roles. For the technical infrastructure, we should have also new roles and responsibility in order to delegate that particular airspace. As the common layer, we tested with the dataset dated 27 of April 2017, with the common infrastructure that is split in several services of the in Europe. This is just an example that was done in a previous real-time simulation. If we have to delegate, it's just an example, part of the sectors of Milan airspace to Geneva, or the contrary, and we have this trajectory. Nowadays, the trajectory and the data are not shareable, and you have to separate this environment from the infrastructure layer. When there should be the mechanism was correlated and was synchronized in a shareable environment, we will have part of this sector of Milan or Geneva should be delegated. And you can manage the entire trajectory of the airspace, you can manage the controller working position, you should have the power of the supervision of that particular area. And you should delegate part of the airspace sectors, part of the Milan sector to Geneva or the contrary. It's just an illustrative, it's just an example. At the beginning, we identified this one in the scenario identification. So the initial real operational needs that is needed for the air traffic service. We are talking in the operational phase, and as well the actor and the process. In the green line, there are some services involved, and so different air data service provider We are talking about different services like flight data distribution, voice data management that has been represented one of the NSP industry. And in parallel to this, we have some key performance indicator aspects identification. It means to have some benefit on the operational efficiency, better capacity, but some benefit also with the business continuity of the contingency. And of the top one, it's quite important also the timing of the delegation process. It should be in a start at the end during the delegation process. Based on this, we should have some 6 use cases to be tested with the delegation of provision, high traffic services at night and low traffic condition, and should be together with the provision of the high traffic services at fixed time that should be combined, because at fixed time you should delegate part of the airspace. Regarding the dynamic and cross-border operation, we have the use case number 3, delegation of provision air traffic services with associated ATCFM position or civil military operation. So it's quite important also to understand the word of the military and general air traffic that should be considered in a shareable environment. And as well, another important use case is related on the cross-border use case and the contingency. I just to spend a quick words one by one, just one slide. At beginning, the first one, we aims to test some sectors from Karlsruhe to Zurich and Geneva space. And based on this assumption, we should use some bilateral coordination as the unidirectional way. There are some assumptions that should be starting the night operation or during the morning. And this is important. There are some preconditions that the supervisor should be agreed about the design of the delegation procedures for the handover. Letter of agreements should be adopted due to the possibility of the delegation among the air traffic service units, and to design a specific detailed procedures when it should be able behind the confined airspace or much more in advance. With the specific one is just another example to use the same DSP services with the 2 different air traffic service units in the cross-border operation. So consider that nowadays we should have a limited boundary of the old positioned on the confined part. This is an example between Italy and Geneva. And with the cross-border operation, we should have a unique trajectory. Of course, it should be some prerequisite. In Italy, we should have also the free route environment. So a unique trajectory between Italy and Switzerland should be able and show some benefit of the services in cross-border operation. Evolution on the technical side about the flight management and flight services should be considered in a free route environment. Most benefit that ATSU 1 and ATSU 2 should be collapsed with the same air traffic ATM data service provider. Another important services was considered during the delegation of airspace among the air traffic service units, considering the ATCFM services. ATSU 1 and ATSU 2 will be considered at the beginning in the blue cycle 1 in the strategical position or pre-tactical position and tactical position. So at the beginning, before the delegation of ATSU 1 to ATSU 2, the FMP position should be able to support the controller in a delegation process in advanced period, and this should be a benefit on the delay process, avoid holding patterns, fuel consumption, so environmental benefit, part of like that. There are some assumptions that we are still considering because this part of the exercise should be able in 2022, and we are building the operational scenario, the needs, and the technical infrastructure as well. Similar to this one is a civil-military cooperation. So by considering a business-to-business services connecting the operational air traffic and general air traffic, we have some sub-use case that will be considered the air traffic service units, national military activities handled by civil operation or that are in a separate environment. And together with this DSP synchronization, we should be connected civil and military operation. Most important contingency one that nowadays in today's contingency solution, we have also one that should be failed for several reasons, and the controllers needs to be run outside of the building, and there are some constraints of the outage of the traveling of the air traffic controller and system, and we will have a less capacity, less position, and also for the different system. In a virtual center environment, if there should be a crash of the ATSU-1, thanks to the business continuity of the replica of the ADSP2, the air traffic service unit is able to manage and to have the business continuity of the replica of the air traffic of the ADSP number 2. And we will have some benefit in terms of other air traffic service units could help the immediately airspace delegation, and it should be, of course, a reduced outage, better capacity and migration of air traffic controller in case of long-term failure. In this project, we have a big partnership of the industry, researcher, air navigation service provider, and we have a lot of real-time simulation with a different environment. Part of this use case should be tested in a full capacity, and thanks for the cooperation of all of you, for the industry and SP, and a lot of that, also the linked party that are linked in this solution. As well, also some CBA in terms of cost-benefit analysis will be analyzed to see the optimization of the cost by the economical part. ENOC is quite strongly dependencies on this project as it's managed solution M3, and is one of the key messages that believes on the virtual center, and also in this user case we can test in real environment. That's all for my side.
Thank you very much, Maurizio. That was already quite elaborate on the operational use cases. Our next speaker is Thomas Buchanan. And Thomas Buchanan is the senior advisor international affairs with Skyguide, as with the Swiss civil military ANSP. He started his career in ATM 28 years ago as the controller trainee for Geneva Tower and Approach, switched to the operational support unit where he took over the instrument flight procedure design team. In 2006, he joined the International Affairs Division, as from 2010 onwards, he's been involved in the elaboration of the Skyguide Virtual Center concept. So that gives a bit of an indication how old this concept already is. The initial ideas already came from 10 years ago. So he provided operational institutional input into the Skyguide program, collaborated closely with DSNA, DFS, in the SESAR-1 program, positioning Skyguide as associated partners to the two entities and opening the possibility for Skyguide of joining the first industrial research on virtual centers. In the current SESAR program, Thomas is involved in the virtual center project activities, taking the lead for all the communication activities. Thomas, the floor is yours.
Yes, good morning, everybody. Welcome from Switzerland as well. I see the limitation of the virtual center already. Sadly, I cannot share my screen. Maurizio, if you could release it, please, and then I'll start my presentation. Sorry for that. Okay. Thank you very much for that introduction, Ruben. What I'd like to do here is take a quick look back into what Skyguide has done over the years, where we stand, and then after that, address one or two perspectives from an ANSP perspective, what we would like to see as potential future business models or where we see this story going on. So on the Skyguide side, currently, or before we started our migration towards a virtual center, we had data centers where the various components, now keeping this as simple as possible, were connected point to point, which means that you had one component delivering one type of signal, message, or whatever it was to another component, which will process and pass it down throughout the data center, making it available, and at the end, providing multiple sources of data to the controller working position. If a new type of external
Okay, that doesn't look too good. I think we just lost Thomas. So much about the reliability of ground networks. Let's give him a minute to come back. If he doesn't, I suggest we continue with the next speaker and wait for him to come back. I'm sure he will come back at some point. Richard, meanwhile, start getting ready mentally, because you might have to take over your presentation then. I'll wait for, let's say, 30 seconds to see if it reappears. I guess I see there's one question that I'm pretty sure, Richard, you can answer, but on the interoperability, but you already answered a bit that you're coming back on the presentation. I suppose you want to do that during your presentation, or do you want to do that up front?
I prefer to have my slide to support my answer, but based on this question, I will also answer this question during my presentation with the support of my slide. I don't know if I try to warm up my voice right now, if I have to go on.
I think I'm going to introduce you, and then just cross my fingers that Thomas will come back after your presentation. So that gives him 15 minutes slack. So apologies for that. We continue for the time being with the presentation of Richard Beaulieu. To introduce him, Richard has graduated as engineer in the École Supérieure des Télécommunications de Paris and started his career as a consultant in Altron Technologies, collaborated in projects for the specification validation and also for safety studies for several ANSPs. After joining Thales Air Systems in 2008, he first went to Thales Australia, where he locally developed a safety team. Back in France, he continued working for the safety and the engineering teams in air traffic management. After joining the SESAR team, he worked on global architecture, virtual center, and the common services concept. He's been the solution leader of SESAR Wave 1, the Project 63 on the virtual center, and still continues to work on the virtual center concept and its operational counterparts of delegation of airspace and contingency. The floor is yours, Richard.
Okay. Do you see my screen now?
Not yet.
Not yet? Okay. Tell me when it is good. Firstly, I want to thank you, Ruben, to invite me to present this presentation about the technical part of the virtual center. For many years now, I work on this solution, and I'm very happy to be here. I want also to associate. Okay. I want also to associate all my partners in SESAR to this presentation. I will nominate some of them during my presentation, but of course, many others are also in this solution in Wave 1. And as you have been seeing with Maurizio presentation, we are a lot of people around the table around this concept. I want to come back on the basic. The idea for me of this presentation is not to educate people which are well aware of what is a virtual center, but more to give a first presentation of the virtual center. So you have already done that, Ruben, through the airspace architecture study, and I will come back on that, but I will focus on the technical part. So the first thing I want to mention is I want to set the scene of what is I call here the classic architecture, and what is for me, for a technical point of view, what is the virtual center. So in the classic architecture, you can have this schema without the voice, because Martin will go on the voice on the VCS part. I will try to focus on the air traffic control system. So you have the air traffic control system, you have all the external interfaces, and the question was about these external interfaces, and you will see how they will change with the virtual center concept. And you have these internal interfaces with the CWP, the controller working position, and with the controller will control a kind of airspace. In general, in most cases, our customers buy a unique air traffic control system. So we provide as one supplier the entire system of that. What is different with a virtual center? Firstly, we have a remote location of the ATSU, whereas the CWP and the ATCO could be remote. which is not in this schema, but could be also the case. We can have other systems for contingency, for example, but not only, could be also in the ATSU. And we will connect to this part for the air traffic control system over a WAN. So about a network. And of course, the performance of this network is different than the local network, and we need to manage that. But to answer the question, external interfaces are more or less transparent at this stage, with this separation in two parts here between the two. So for me, it is very important as a takeaway that we create this interface, and this interface is over a WAN with a different performance. The consequences is also that we, as Ruben said, but I think it is the second step, we can have what we call now an ADSP for ATM data service provider, as it is identified in the airspace study. And this ADSP could be independent of the SC. So we move from this fully integrated system to a creation of an interface, performance, perhaps not issue, but difference. And we have also perhaps a new stakeholder into this image. Now I want to go back in the delegation of airspace and contingency for technical point of view. So it's in line with what Mauricio said previously. We have here one ADSP with, for example, two systems with external interfaces, and we can have a connection with this ADSP to HC1, I can say the green airspace, and here for the second airspace, the blue airspace. And what is what we can do is to delegate to the ATSU2 the possibility to control the green airspace. What is, for me, quite important to note that we have already demonstrated in wave one that all of that is technically possible, including with legacy interfaces. I will come back later on the services interfaces, but I think it is important to note that it's already possible, and we have demonstrated that with a coupons member and with Ungaro control to be able to have that in the ADS with the virtual center concept. I just want to mention a particular issue from a technical perspective, which is the cross-border. I put here an issue, but we have to fix it for sure. Cross-border is when you want to delegate an airspace beyond your border. You can delegate a complete sector, like if you want to transfer all the blue part to the green part, as it was previously, or you can only delegate a part of that. The issue is more when you want to delegate only a part of that. So you want to transfer only this blue part to the green airspace in this case. And the consequences are you need to connect the air traffic control, the two air traffic control systems. So imagine that if you want to have multiple ADSPs, you need also to create interfaces between ADSPs and not only internally in the ADSPs. If you are only in one ADSP, it is quite simple, I can say, to do that. What is for me more difficult could be also that we can have input, also interference with the external interfaces, and I come back on this question I had, because to have this to have the display of this portion of airspace, you need of course to have the radar track, you need to have the meteorological information, that is for the input, but you need also to manage data, for example, with data link next authority and all the message you can have. And that is the issue I see here with the cross-border. So as a takeaway, I say new interfaces between ATS system and impact on external interfaces. In some cases, if we want to go into complex use cases. I want to come back and what Ruben already mentioned in the airspace architecture, it's the service orientation. And I think it is very important to know that between the ETSU and the DSP, even in particular, if you want to have a different supplier between the ETSU system and the ADSP system, you can go to a service to services with all the possibility Ruben already mentioned, with for the system perspective to change this part of the system, respecting the services to deliver to different ETSU. To not over complexify the schema here, but you can imagine that you can connect these services to multiple ETSUs and also to have multiple ADSPs for an ETSU to be connected with. If you have multiple ADSPs, for sure, you need also perhaps to create some services between ADSPs. So as a takeaway here, many services have been already developed and validated, and I will come back on that in the next slide, in SESAR, in the wave 1, but also in wave 2 and wave 3. And I don't know how many people are aware of that for the moment, but working group UK have been created, dedicated on this part. It is working group 122. So just to give you another view of what was done in wave 1 for service perspectives, I have this slide. With all the services, I don't want to go into too much detail, but just for you to know that the size of the rectangle is about the complexity. So the most complex service, it's about the flight data. Darker is the color, high maturity we have of the definition of the service. So exactly the same for flight data. It's a very mature. It's not the case for all the services. And about the green tick and the red cross, it is about the validation done in wave 1. So once again, wave 1 have been finished last year, and we will continue that in SESAR to go into other services and to have more maturity on services, impact from the different use cases on these services, but also we have to validate some of these services. Prior to conclude, I just want to mention that we have already some initial implementation of Virtual Center, and I can give you 2 examples. One example is when you have here an approach, and this approach is closed at night and come back to the ATSU. That is something we done from different customers. And another example is about the Tallinn and the Helsinki ACC, where we have just delivered to our customers the possibility to have a cross-border and also this splitting over the one. I just want to say that we have several systems in operation or close to be in operation with this primary virtual center concept. As a conclusion, virtual center concept is a key concept of the AAS, and Ruben mentioned that in the introduction. First implementation already exists, but it is a preliminary part, and in general, as far as I know, is with a Unix supplier for the moment in operation. And the next step to go further into the concept have to be developed in SESAR or in the Eurocarrier working group, and the impact on the new operational use cases on technical interfaces, in particular cross-border, as I have mentioned. Specific architecture, as I said during my presentation, we can imagine a lot of different architecture with ADXP, for example, services and interfaces, and we have to work on this part. And we have also to focus on the degrading mode, because this degrading mode could have a major impact on the technical part. And as a final takeaway, I want to highlight these 2 points about the safety objective and the cybersecurity protection of the whole system, ADSP plus ATSU, which is, I think, the most important for our community. Thank you very much.
Thank you very much, Richard. That was quite good, elaborate. I think really clear that it's focusing on the technical aspects of the virtual center. I keep an eye on the questions that I see coming in, and I also see that Thomas is back. Welcome back, Thomas. I'm happy that you're back. Can you please unmute for a moment? Yeah.
Yes, I'm here.
Okay, good. So I don't know if you actually noticed, but we lost you, I think, quite at the beginning, at the second slide or something.
Well, somebody sent me a message saying it was a very good rehearsal, so I'm ready to go now.
That's good. Now, I would like to ask you, looking at the questions that I see coming in on that are quite close related to your presentation, I'm going to just highlight them for a moment. So I see 4 questions that are here related. One from Alex Kowalski, from Michel Artieri, from Konstantinos Simaikis, and from Paul Neri. And they're all related to sovereignty, to revenue issues, to legal issues, liability as well, and institutional issues, saying like it's not a technical issue. It's actually all more about institutional, about legal issues. If you continue your presentations, could you keep those questions in mind and maybe meanwhile already start answering those, also to gain a bit of time on the questions and answers? I think it's quite important that you take the time to address those if you can. I give the floor to you again.
I hope that it'll work this time.
Worked last time, it's just that it didn't continue working.
Well, in that case, I see that Thales has become our contingency. Thank you very much, Richard, for jumping in. Anyway, I'll try and take this through again. So what I wanted to show, just a sec. I want to take you through the Skyguide story. Where do we stand? What have we done so far? Where are we going? So if you look at the data center, and I'm sorry if I'm repeating myself, I don't quite know when I was kicked out of the previous presentation. If you look at the data center, currently the components will work point to point, exchanging data from one component to another. If you've got external data coming in, this will be processed by several components. The components in turn will generate the data on various data streams to the CWP. If a new external data source comes in, you most likely will have to generate a new component within the data center and therefore relink those components across the various existing components to make the new type of data available. In the SkyGuide situation, we had to do that for the Geneva West ACC and also for the East ACC here in Wangen, near to Zurich. In the new model that we've set up and that we are running, we have an enterprise service bus which serves as interface between all the components and also generates the necessary data between the enterprise service bus and the CWP, it's the controller working position. And for that, we no longer have to refer to them as the West and the East ACCs. They're just connected controller working positions, and never mind where they're located. If a new type of data comes in, this data will be hooked up to the enterprise service bus, and the component needed to transform or to use this data inside the data center will also be connected and make the whole interconnection between the various components a lot easier. In our concept, we refer to the controller working position as the front office, and all the technical elements, the components, the data centers, the external data as the back office. It's a model that, of course, already exists in other domains and is probably relatively new to the ANSP community. On the operational changes, in our old legacy environment, you'd have a technical room below the area control centers, one in Geneva and one 240 kilometers away in the Zurich region, where the area control center would be above the technical room and the airspace for control located directly vertical above that one as well. You'd have exchange of data between the technical rooms on both sides and the external data that we already receive, be it from Eurocontrol, from Network Manager, or other sources. What we have achieved so far, or what we are transferring towards at least, is the creation of data centers that are location independent. We are going to be using the data center here in Zurich to source data to both our air traffic service units, West and East, and we'll use the other data center as a cold standby to be able to come in as a contingency to the first data center should it fail. We've also got external data from two sources, one of them being the SNA as a prime source, and a redundant data service provision that is going to come in from eNav, both on the core flight cloud services. And of course, we expect that those two data centers, again, will be redundant one to the other. The flexibility that we are achieving will allow us to transform the airspace from what we used to have in a vertical constellation to a Swiss-wide, flat and modular layout. We could imagine that the upper airspace is going to be controlled from the West sector, and the lower airspaces could be controlled from the East sectors. And we still could have standalone independent functions such as a TMA or CTR that use part of the data but are not merged in the concept of collapsing. In the SkyGuide vision, we see one airspace by one logical system. Our SOA architecture is realized with an external enterprise service bus. For us, it's a TIBCO solution, and it allows deploying virtualized platforms. It allows us to provide a logical harmonization and unification at application level. It'll allow us also to reduce technical infrastructure through data services. Some of it will be removed and be sourced externally. It allows staff optimization through flexible airspace allocation and function centralization. We could have the owners of a specific type of function in the technical room all located in one location and sourcing the data to the other location. Just as much as we could expect that the air traffic controllers, instead of having 4 night ACC controllers in the west part and in the east, we could collapse the airspace and make that available through one sector operating for all Switzerland. As mentioned, we're going to source data, the core flight cloud services. We've signed the contract now for the test data, and that data is going to be sourced from Paris to SkyGuide Zurich and thereafter disseminated through our systems on a location-independent manner. On our ADSP business model perspective, we really want to have multiple ADSPs available. We want to have a real market, be able to put the ADSPs onto market conditions and choose the best value for money. For that, we need standard open interfaces to be able to exchange data, irrelevant of who is the main manufacturer behind the solution chosen. On the ATSU business model, we want to be able to control everywhere to anywhere. We want to be able, if needed, take across airspace of congested area. We had the situation of the Karlsruhe sectors, for instance. Why not take those across to areas where we've got more available capacity and reduce the pressure on the system by shifting airspaces across Europe? As mentioned also, on the contingency side, in the resilience case, we want to be able to guarantee service continuity. If Zurich should fail, we want to be able to shift across to Geneva or the other way around, but we also could imagine taking cross sectors from an ACC that has failed totally. On the scalability side, the COVID experience shows also that we have a need to continue the ability of reducing to the strict minimum. In Europe, when the traffic was down to close to nothing, all the ACCs were mostly operating still. We had sectors open with 1, maybe 2 aircraft per hour. If we managed to join and merge those sectors, we could imagine fewer sectors controlling the little amount of traffic that was at the beginning of the COVID around in the European sky. We see the virtual center as being the key trigger of the dynamic airspace configuration. We want to have the capacity balancing beyond the local area of responsibility, which means that we want this ability of taking across sectors that are not necessarily immediately joining our ACCs. The airspace delegation itself, of course, beyond the neighboring NSPs, we could imagine a situation where some of our airspace may be given across to London, or London airspace given across to Poland. You can imagine any kind of scenario, depending on the pressure on the system, the need of capacity, or the unavailability of some sectors. On the virtual center implementation, we want this to be a joint venture between all partners of the system, which means ANSPs, of course, as primes, the future ATM data service providers, be them ANSPs or other type of data service providers, manufacturers, the industrial partners, the regulators, oversight, or questions of that coming in as well, be on a local level or on a global level, if it's transversal activity, maybe EASA. We want the ANSPs to be part of the definition of the future AGSP ATSU concept. We do not want to end up in what we call an SAP syndrome, where somebody develops what is perceived as being the best solution for everybody, and it gets imposed on people. We want the ATSU not only to be a remote terminal, but we want a certain amount of flexibility available to be able to test functions on a local level or to develop specific functions on a local level for interface purposes for very specific local geographical issues. So that is a bit of the vision of where we at Skyguide are heading to. And Ruben, I hope that this time I was not kicked out of the meeting.
No, you were not. Absolutely not.
Okay, perfect. Thank you very much for that.
Thanks, Thomas. Thomas, now that we're still with you, before we go to the last presentation of Martin, can you dig in a bit on the today's reality on your collaboration, on your delegation of airspace in the coordination with DFS, with the DSNA, maybe with ENAF as well? Can you elaborate a bit on that? So both in terms of training, in terms of liability, safety management systems, things like that.
So the main partner we've got airspace from is DSNA France. We operate parts of southern Germany as well out of Zurich. And we've got a tiny bit of Italian airspace, just as much as Italy has got quite a bit of the Swiss airspace on the south part of the Alps, allowing approaches into Milano. These delegations are fixed time delegations, and it actually is not in the sense of virtual center. It's our own sectors that extend beyond our national borders. With France, we've got a very specific defined area of responsibility that France has delegated to us to allow operations into Geneva. We've also got one platform in the proximity of Geneva which switches in accordance with the needs of the runway in use in Lyon. However, all the institutional models on a fixed basis are easier to define because you know what the requirements are. We know who is responsible for taking across the responsibility of the sectors. And we also know that on our side, if we implement a new procedure for Geneva, it's going to be the Swiss NSA authorizing the operation of the procedure. However, this is done in close collaboration with our colleagues from DSNA, who will also approve that what we intend doing in the airspace fits their purposes in the end. So on a fixed basis, on a non-virtual center or non-dynamic reconfiguration, the whole discussion is relatively, brackets, easy to manage. It becomes, of course, a lot more complex, and I think the recent publication of the SES2+ recommendation shows also that a lot has still to be done on the European level to make this full dynamic airspace capability available beyond the local or the neighboring ANSPs. There's a lot of work still to be done. I'm confident that within the next 2-3 years, Europe will help us find the solution to all problems.
Thank you, Thomas. Okay, before we continue with all the questions and answers, I think it's almost exploding at the moment. There's so many questions coming in, so it's clearly a hot topic. But I'll postpone the rest of the questions and start first with introducing Maarten here. So Maarten, welcome to join the stage. So Maarten joined Frequentis over a decade ago. He has a sound background from telecommunications. He helped develop to advance the introduction of voice over IP in the air traffic management industry. As the product manager responsible for networking products, Maarten has been part of setting up the first live air-ground calls using voice over IP equipment to migrating complete countrywide networks around the globe. Within Frequentis, Maarten is now responsible for the ATM voice communications area, the flagship product of Frequentis. By actively participating in the SESAR project around the virtual center, Maarten contributes to implementing the virtual center concept in the CNS operation. Maarten, the floor is yours.
Thank you, Ruben, for the introduction, and welcome from my side here in Vienna. I will talk about the virtual center related also to the concept of voice communication. Originally, it was planned that Richard would be the predecessing speaker and he would look into the ATM system side. And of course, when looking into this, there's also the live voice communication side. And I would like to start with the picture also Ruben has shown in his introduction, coming from the European architecture study. And here we see the idea. So what is the goal of the change, and especially related to voice communication, which was also always a very system which is built on reliability, resilience, and availability. How do we keep such a thing in such an infrastructure? And that's what I would like to elaborate about in my presentation. So we want to integrate the communications, and with the communications, there's obviously the challenge that there is a part where I would say the rubber hits the road, and that's the radio network. The radios and the VHF is obviously local to the coverage that is needed to reach the aircraft in the air. So we need to enable the access to the local radio network, which obviously poses a certain challenge compared to, for instance, providing networked radar data, which is already solved in the European architecture today. Looking into such a voice communication concept from where we are today, where we have the independent silos of communications, navigation, surveillance, and you actually can see these silos from a technical concept often in the technical rooms at the ANSPs inside Europe. We want to come to a more open infrastructure. And I'm going to talk about separation, not about separation in the air, but separation between the control room and the data center, and between the data center and the radio network. And this idea of separation enables also new ideas. And I've been watching the questions that are coming along, which are especially also directed towards the ideas of the virtual center and how rating works, etc. Probably I'm not the right person to answer them, but I see a lot of benefits coming from this idea of virtual center and the separation of the control room and the technical machines providing the services, that you can, let's say, with one technical data center or two technical data centers, as Thomas proposed in SkyGuide, actually can move the provision of the service and the 2 wards control rooms to different control rooms and create more flexibility also inside one ANSP, having different ATSUs, and making that an infrastructure rationalization, which actually also makes sense. And the second benefit we see is when you have this service provision model, that you can provide the service provision separated from the controller working position, and with the right standards. And that's probably also why it's very good that there is now the initiative to do a standardization, as Richard presented with the working group 122, to create the concept of an integrated controller working position, because the controller working position is no longer part of the silo. What does that mean for a voice communication system? And that's actually a very important part. We need to abstract the local implementation of voice. What we see is that there's a lot of local small differences in how voice communication is treated, how a radio network is handled, how the radio failover work, how to maintain the safety towards the local regulations and what comes from the local regulators. So the working position and how the working position works inside the control room needs to be independent, so that the operational model doesn't need to change. I don't think the virtual center will become a reality if all the operational rules and needs and how a control room works in a certain country needs to be adapted to one common model. What does need to happen, and that's also what Mauricio has mentioned, is that there needs to be some sort of agreement on the operational procedures, how to delegate airspace between ATSUs or ANSPs.
Martin, can you interrupt you for a moment? I'm
Yes.
looking at the chat and I noticed that quite a lot of people are not seeing your slides. I do see them, but can you maybe try to take your presentation out for a moment and relaunch it, so reshare it?
Sure.
But if
Yeah,
some reason it's not working.
Yeah, I will stop share, and then I will reshare and see if that helps. So we wait a little bit. Is the presentation back online?
I definitely see it. Okay, let's hope that worked. Please continue. Sorry for the interruption.
No problem, Ruben. And it's always good to have some sort of a backup or stop me if there's something technically not working. So I was talking about the independence of the local rule sets and the local operational model that, compared to the technical systems providing these the services. And from a voice virtual center, how would that look like? Yeah. So how do we separate? How do we separate the control room and how do we separate the radio network? And within the virtual center model, the architecture of a voice virtual center, as I'd like to call it, revolves about the idea of these data centers. And if I would have one ADSP providing a service to certain ATSUs, you need to have access to the frequencies. You need to have access to the ground-ground communications. There is a standard for voice over IP. It's also a Eurocase standard called ED137. And of course, we want to build on these standards so that using IP networks, we can build a virtual center. And what we introduced for this virtual center is a new service called the frequency service. And the role of the frequency service is to abstract the failover and the local rules of making a radio network available to the voice ADSP. You may have the frequency service itself as part of a technical service inside the data center, but you might just as well deploy it locally because it may bring some more resiliency, as I will show on the next slide. And the these ADSPs now are depicted on these slides as, let's say, two independent ADSPs, but the let's say the true benefits of the virtual center actually come about when you interconnect them, as also shown in this airspace architecture study. The interconnection creates the additional benefit of being able to flexibly hand over responsibilities between now ATSUG 1 or 2 and ATSUG 3, but also to create more resiliency. For instance, there's a data center outage, a contingency scenario could come into play where one data center takes over the role of the complete other data center just by accessing this from the different CWPs. So virtual center goals achieved with this architecture: flexible allocation, basically being able to access frequencies from anywhere, the ability to have cross-center sector delegation, moving responsibility in a safe way, and also contingency to create a data center multi-redundancy, and what I would call a non-cooperative takeover. So normally there would be a cooperative takeover. If there's an outage, then the takeover of airspace could also be a non-cooperative way. There's a lot of ongoing work inside the Solution 93, which is led by Maurizio, especially on the operational aspects. Maybe as a closing slide, we did a validation as a part of 1603, which was led by Richard. And especially for voice, we showed a validation last October in a validation event which was held in Vienna. The validation included voice data center and a swim broker in Vienna, with positions stretched out to Langen, Geneva, Bretigny, and Budapest. So they would have all access to the ADSP located in Vienna. A second voice data center in Madrid, with positions in Southampton and in Madrid, and a shared ground radio station simulation, which was actually also hosted in Vienna, where we successfully demonstrated the delegation concept, also with coordination using voice communication, which was done between the Geneva and the Langen ACCs in a validation mode, so not with real air traffic. With that, I would like to conclude my presentation. I hope that the last part of my slides were visible to everyone, and otherwise I guess that they will become available later on. With that, I hand off to Ruben.
Thank you, Martin. I see on the chat that people were happy after the reset. I can actually see it, so it did help. Good. Take off your presentation, I wanted to say. So, thanks all for your presentations. I do notice that you have all kept a good eye on the questions coming in and already start answering quite a lot of those. So also for people listening in, you can already see quite a lot of answers coming up there. We still have 17 minutes left, I guess, for a bit more of debate on a couple of things. I tried to group them a bit. Whatever we're not going to be able to answer in that time, we will address later on. So I'll follow up all the questions with the speakers here to make sure that we provide answers, which we publish with the recording afterwards. It will probably be available in a day or two. So I'm going through a couple of different topics here, and I'm going to start, I guess, with either Maurizio or Thomas, with a question from Paul Neering, who says that COVID took everybody by surprise. So using it as an example is too opportunistic. Merging into less centers would be a risk. Now, I think personally that the whole message of the airspace architecture study was certainly not to reduce the number of centers. I want to be quite explicit about that. So by separating out the different service layers, we may reduce the number of flight data processing systems, so the ADSPs, but not the area control centers. Maurizio, can you please elaborate a bit?
Yeah, sure. Okay, the intention is not to reduce the personnel, but to increment also some activities and technical personnel, especially for the ATSE part, and the air traffic controllers, because as well is flexibility of a human resource. It's not meaning about the reduction of the people, but just to have the right people, and also for the virtual center opportunity, it will give some opportunity and some scenario in order to implement new technology, new technical people, new engineers, in order to implement and to support the control system in a virtual center as much as possible. There are some ongoing discussion about also see the regulation and activities, and as you know, just open a parenthesis of EuroCAE, as Richard said before, working group 122, that is aimed to standardize part of the procedures and in ongoing activities inside solution and field. Okay?
Thank you. Thomas, you want to add anything?
No, I think maybe it was from my presentation I made that statement that in COVID we could have reduced the number of air control centers more. Probably it is a bit opportunistic, however, lessons learned. Even in the Swiss situation at night time with low traffic, we are operating a certain number of staff in both ACCs. If you manage to collapse the airspace, we can reduce the number of controllers. So maybe, yes, COVID is too opportunistic. It's definitely too early to be able to do that. But if you want to have a full scalable European system, in case of a downturn of traffic like we've had over the last few months, virtual centers will definitely help us reducing the amount of people having to sit in an operative room looking at 1 or 2 aircraft per hour.
Thank you, Thomas. I'm going to switch for a moment to something completely on the other side of the spectrum, more on the technical side, just to try to distribute the topics for discussion here. Zooming in a bit on security and reliability. Now, also noticing, Thomas, that you disappeared for a while, and that led to some remarks about, well, so much for reliability of the networks. I think, first of all, and thanks Detlef Schulz for pointing that out, the quality of service, the SLAs that we have in our home networks are very different from that we have in an ANSP for safety critical services. But okay, having said that, I got a couple of questions here on how to deal with cybersecurity issues, difficulties with wide area communications implementations. I guess this is typically a question for both Martin and Richard, and maybe Martin, you can start.
Yeah, sure. Let me start with cybersecurity. I think cybersecurity is a challenge, but the challenges are not different than if the virtual center would not be here. Introducing let's say with the introduction of voice over IP, newer ways to access radio networks and access ground networks, the introduction of standard computing mechanisms, all the security paradigms which were maybe far away, especially from voice communication, but also from other systems. It's becoming more and more a standard IT issue. So we need to, as a community, solve these security issues, let's say, in the normal industrial way you treat IT security. So look at your threat model, look at the access and authentication model, and it's not different in a virtual center as if, let's say, everything would be local. The idea that an ANSP and the technology of an ANSP would be on an island is anyway something of the past. So this is something we need to work on as a community.
Thank you, Martin. Richard, you want to add anything?
As I said, we create a new interface. So by definition, we need to study in particular this new interface, and in particular for a cybersecurity part. But agree with Martin to say now it is something we are able to deal with, and we need to, in particular for the EuroCAE working group, to focus on this part, because it was not the primary focus on the SESAR project. So definitely it is something we need to address now.
Thank you, Richard. I'm going to stay for a moment on the technical side and notice that there are a couple of attendees here that are being a bit cynical about the pace of evolution. So looking back at technology evolution in the past, things can actually go really slow, taking up to 25 years for relatively simple data exchanges. So if we want to do something complicated like this, how are we actually going to get there? And I think it's a question probably for everyone, and I have no clue if anyone dares to answer this. It's not an easy answer, I guess. Who wants to take the floor?
Let me start, because I think there are two sides to it, and I tried also to highlight it into my presentation. One of it is make it technically possible, which I think from a concept perspective has been shown successfully in the validation, that it is technically possible to delegate airspace, to delegate also between different ADSPs, to create this. Yeah. And the second part is the operational side, and I saw a lot of questions flashing by on controller rating and how to deal with this and how to manage airspace, which maybe you are not rated for, and I'd leave the floor maybe to Thomas and Mauricio to answer those. But from a technical perspective, I think now we are, let's say, have the technology, and the technology also in a phase where these things actually can become reality and bring a benefit also in a CBA analysis. And I leave the second part to my other companions here.
All right. Who dares to step up?
I'll try and give some of the answers. I think we've realized over the years in which, and you mentioned at the beginning, Ruben, Skyguide has been down this path over the last probably 15 years now, trying to figure out how we can make this a reality. And I must say it is a very complex discussion. When we started off, we were sort of looked at or considered as being the odd people out of a already standing old network of independent area control centers, if we can call it like that. And by getting the ball into movement, just that was a very big effort on the European side, the lobbying needed to make people understand where we're trying to go to. And finally now seeing that the airspace architecture, for instance, considers virtual centers as being the new trigger will definitely give momentum to the change. You've got various groups that are going to be called into life. We mentioned the EuroK groups. A new group is also going to start off on the virtualization standardization. A lot of work coming. I think we have to get together and understand where we want to go, how fast it's going to go, and if we've got more people on board, it's going to speed up.
Thank you, Thomas. Now, I don't know if anyone else wants to speak up. Otherwise, I would like to show for a moment something that comes from the high-level roadmap from the transition plan of the airspace architecture study to relax people a bit, I think, because I think people maybe have the impression by now that we intend to deploy this solution, let's say tomorrow, and that is certainly not the case. I think there's definitely a stepwise approach required here. There's still quite some research ongoing, including, for example, on the controller rating, if you want to make that more generic, but also on lots of other aspects. So just to share for a moment, this is from the Airspace Architecture Study Transition Plan. Again, you can just download this from the SESAR website, and I zoom in here on the roadmap, high-level roadmap, to show the time path that we have towards 2035. So I'm realizing that we're now only in 2020, so there's still quite a lot of steps ahead of us. So it starts with the ECAG-wide implementation of cross-border free route, improving air-ground, ground-ground connectivity, launch an airspace reconfiguration program, and an operational excellence program. So I didn't discuss those aspects of the airspace architecture study because that wouldn't fit in the context of, or in this limited time that we have available. So you'd have to look at the study to understand the full scope of the airspace architecture study. But there is a lot more that is required to pave the way to be able to get to a more flexible and resilient architecture. So in parallel, the Commission is working on conducting their study to understand what the regulatory, the certification, the safety aspects are related to changing this framework to a more service-oriented architecture. And only then we go to the next step of early implementation of virtual centers, dynamic airspace configurations, the higher levels of automation, capacity on demand, let's say in an early stage, more as pilot projects before, and then the last stage is to actually go to real service-oriented air traffic management. So just to set the scene, this is a vision that we're discussing and presenting here, and it will have to be done step by step.
Just to add something, Ruben, that fully agree with you. We have to progress step by step. As I said in my presentation, we have already delivered for the Finland and the Estonian customer a system able to do most of these use cases as a cross-border. So it is possible, as Thomas said, also for the Swiss market, if you work on a specific project to progress. And to do that step by step, we will see more practically, I can say, all the issue we can have to go for a wider part. And definitely we need to fix some issues we are raised when you want to be wider than only 2 countries with one supplier, for example. But it is a first step, I can, to progress in that direction.
Thanks, Richard. So it's clear there is definitely still work ahead of us as well, also on the research side, while we're paving the way on all the other layers that I showed at the first slide of the airspace architecture study. I do realize, even going cross-checking again on all the questions that we have, that actually we are covering quite a lot of those, but there's more complicated topics in there. And one that I'm hoping, Thomas, you can, and maybe Maurizio as well, you can elaborate a bit on, which is on the certification of controllers. So a working license that actually works cross-border or all the way to a European flexibility. How far is it realistically feasible to push in that direction? And what are the results that we have so far from the research that we've been doing on that?
It is a very good question. Thank you for that one. I think the issue we've got is that we have to get away from a specific sector validation. And 2 projects currently, well, one is just finished, sorry, that was in the first wave of SESAR, which has run over the last 3 years, which looked specifically at what the needs are of an air traffic controller on a sector that he doesn't know. So there was a paper exercise looking into the various combinations of traffic, what elements is he missing. In the second part now, we've just started a new project where we're looking specifically on, again, the specific delegation needs within an ANSP, and we can imagine the discussion between a Geneva controller taking across Zurich airspace or the other way around. We could imagine Prestwick, Swanwick exchange of controllers. What exactly does the system need to provide to make an air traffic controller comfortable at work? Various questions that come along will be, what level of automation will the air traffic controller need? Decision-making tools. What barriers will the system provide to make sure that the controller applies the airspace to neighboring ACCs correctly? So there's going to be a shift in part of the automation and support functions of the air traffic controller to the machine. So there's going to be a give and take there as well. Now, the licensing part, we are looking at how can we make the recency available for air traffic controllers on the entire Swiss airspace. Now, of course, the entire Swiss airspace is about as big as one of the air control centers in France, so probably it's not going to be all too difficult. I don't want to underestimate the work there, but it's going to be more and more complex when you take across airspace that we don't know. If we delegate very congested airspace from the core area to maybe boundary areas of Europe where the traffic is maybe easier to manage in normal situations. The work is still going on, and we have already in the current phase of SESAR 2 programs or projects running on this topic. So we expect to have a white paper available at the end of the SESAR program, that's 2022, which will give indications of how we see this management and allow the European legislation to change accordingly.
Thanks, Tom. I guess I did want to give you the floor. I just wanted to introduce that. Go ahead.
Just to complement. This is important to not talk about only the airspace delegation, but the airspace of air traffic service units. In the context of a cross-border operation, we had to have a specific exercise in 2022 that we will test some evolution on the technical side about the trajectory framework. So flight data distribution, flight data management, they work as it is in a virtual center, but with the cross-border operation and all the between the boundaries should be also considered and according some regulation and standard of the cross-border operation. Previously, Project 60601 testing in a SkyGuide direct route with cross-border operation. This is something that should be implemented with the sharing of the data between air traffic service units. And secondly, we are not alone, because by now, as mentioned, there is also another project that supports the virtual center in Wave 3. So part of the evolution from V2 to V3 transition should be support on the services about the dynamic airspace configuration, ATC FM. So part of the ADSP is just growing up to support the delegation.
Thanks, Maurizio. I do look at the time. It is 12 o'clock spot on at the moment. So we need to start rounding off. There is one topic that I would like to still address. It's again a complicated topic. I think like any of the questions that come in, actually, it's very interesting, but it sounds a bit of anxiety, but it also means that it's like a good sign that we need to be really looking good into all these complex issues. I mean, the vision is quite straightforward, I think, but the implementation of it is not all that straightforward, and there is still good thinking required to get all the steps right. Now, I just got a trigger coming in on the questions that we missed an answer on the revenue, and I think I'm going to expand that a bit more. So revenue as in ANSP route charges, let's say, as a revenue for an ANSP. And if I expand that a bit more to a generic question, then I would come to the topic of business cases. So looking at all the different service layers, so being originally only an ANSP, and now we have multiple service providers at some point in time, or being able to collaborate, being interchangeable. How does that build a business case? How are our stakeholders, you as stakeholders, interested? Why would you be interested in moving here from a business perspective? Who wants to take the floor? Someone has to step up. You're the speakers here.
I'll try and give it a first throw. If you look at the proposal for the SAS2 Plus reform that has come in, one element that is in there is the single unit route charge. On the business case itself, what we're looking for is an average route charge that would be applicable throughout the entire European airspace. Now, of course, this is going to be very complex. I live in, sadly, one of the most expensive countries, I was going to say in Europe. We're not really in Europe all the same, but anyway, on the European continent. So how do we make sure that we can operate correctly with, at the end of the day, an adequate value for money for our controllers operating at the center? So all these questions, I must say, are probably have to be thought across. We have to look at the performance management. How do we look at route charges? How will this cost of service be flattened in Europe to make this unique single rate available to everybody? And I'm sorry, I'm answering a question with a different question. I think we need the next 2 or 3 years to find the adequate answer to this mechanism, how it's going to look like.
Maurizio, you look like you have something to add on this.
Well, at the beginning, we made a business model for the data center, and what Richard completed successfully, and give it to us the basis to build the operational use case at the beginning. I think so that should be some benefit in terms of also for the network, flexibility of human as well. In terms of cost benefit analysis, we have to do a lot of work, because we intend some cost in the virtual center as the virtualization infrastructure and operational costs as well, based on the rate and the taxes on the across Europe. There is some things that is working among the solution. I think that is quite important.
Thanks. I think that what I would like to add here, just my thoughts on it. Yes.
Just I want to point out, for a technical point of view, as we have created this new interface and we have a relationship between two entities, and if there is some business between these two entities, we can perhaps complexify this interface due to this revenue issue, because you have to know how many data is transferred or how many flights or something. And as it was previously on internal interfaces. You don't care about that. Now, if you have some revenue, you can complexify these interfaces. If I want to give you a very simple simple example is like if you want to buy a ticket, a train ticket. As you want to buy it, you complexify the whole system. If you can take a train without paying, the system will be less less complex. So be careful of that. When you want to have competition, you have also to see the impact on the system side to measure the revenue and this part.
Yeah. So I think we're clearly touching upon some topics which are out of the scope of the technical and operational research that we're doing here. So they are related to charging, business models, competition models, the needs for protecting spectrum still in the end, so which may not always allow for competition. The liability, the certification, safety aspects, lots of things that are being investigated at this very moment. I think that I'm going to conclude here, because we are running out of time, by explaining that, and I think the last slide of Maurizio showed that pretty well. That was just the partners of Solution 93. There are actually more partners than just those involved in the development of Virtual Center. Everyone in our program is interested in where this is going. There is clearly an understanding that we are moving towards a service-oriented environment. That's just unavoidable. It's where we're going. Now, the question is at what pace and how do we build it in such a way, including all those regulatory aspects, that we build the right business cases to build every step in a positive way. And I think this is why it's so important to treat the whole evolution of this in an integral view, from the services, the regulatory, and the airspace, and the technical part. All has to be done together to make this work. But if you take a step back and look from an airspace user perspective, you do see that the system will become more flexible, more scalable, and more resilient. And in the end, the whole system is built for the airspace users. And I think that's something which is important, but it's also why we do have to buy in from all our stakeholders in this development, even knowing that it's still quite ahead before we're actually reaching the vision. I'm going to conclude here. It's now 8 past. We already ran quite over time. Actually, I'm proud that we addressed so many questions which were extremely difficult. I'm also really proud of the speakers here that had the courage to step up to this panel, which was complicated and it was certain we were going to have difficult questions, and you were willing to stand up. I really appreciate being here. Thank you also to people that have listened into this. And I would like to welcome you to the next webinar that will be next Tuesday, next week on CNS. We will continue all the way to the end of the year, hopefully beyond. And thank you for now. Goodbye, everyone.
Thank you. Bye.
Bye.
Bye.